So here I have a SolidWorks assembly, which I'd like to do a topology study on this yellow component here. What you do before setting up a topology study is you will first define a part that fills in sort of the maximum area you have to work with. And then the topology study will remove material to sort of reduce the weight of that component for the most part. So I'm going to just create a new study. I can do this within the assembly, and I'm going to choose a topology study. When I select topology study, it then asks me to choose the model I'm working on. So it can only be done on a single part. I can't do this for the entire assembly, but I can choose a single body to work with. So I'll choose this component here, and that's my maximum size model. Once it creates the study, I can go through and set this up much like I would a linear static stress analysis. I can add fixtures. So I can do fixed geometry on the bottom here. And I can add loads. So I can add my forces just like normal. And I'm going to apply forces to these holes, and I can specify directions. Let's just use this face here. And I'll add another force to this. Once I've specified all of my forces, is when the actual interesting part of this starts. So I've set up all of my forces, and then that's where it changes from how you set up a linear static stress analysis. Because now I get to add in goals and constraints to this. So what I have available are the best stiffness to weight ratio, minimize maximum displacement, and minimize mass. So I'm just going to stick with best stiffness to weight ratio. And when I set that up, it's going to try to keep the best stiffness to weight ratio as its end goal. And then I can specify how much mass I'd like to reduce this by. So I'm going to reduce this by 70%. So it's going to try to end up with a part that is 70% lighter than what I started off with. And it's going to still try to keep the best stiffness possible. What was added in 2019 to this is the ability to add frequency constraints and the stress factor safety constraints. So I can take a look in here and I can specify a frequency constraints trying to keep the first mode shape natural frequency below a certain value or above a certain value or between two values. For now, I'll just leave it with this one constraint, and we can see how it makes a difference to add those later. So I've added the one goal there, and then I can add in manufacturing controls. So within here, I have the ability to add preserved regions. I can add preserved regions. I can specify thicknesses in certain areas. I can specify symmetry, and I can specify a specific demold direction. So if I am planning to mold this, it can make sure that the resulting geometry will come out of a mold from a certain direction. The preserved region lets me define areas that are not going to be removed. In this case, I don't need to have any preserved because I also have the ability to control the preserved region based off of my study properties, so that any regions with loads and fixtures are automatically preserved. So you don't need to add preserved regions if you already have applied a load or a fixture to a face. In this case, though, I just want to use loads only. So my face with the fixture can be removed. We can add our thickness control here, specifying a minimum thickness that I would like. So let's just say 10 or something. And we can also have a maximum a maximum thickness that could be left. And another useful one is the symmetry. So I will add a symmetry to this. So I'd like to create symmetry about this plane. And what that does is in the resulting simulation, it will make sure that the materials remove symmetrically from both sides of this plane. At this stage, we would create a mesh and run the study. Meshing is fairly important in a topology study because the finer your mesh, the more options it has to remove elements. I am not going to run this because it takes a decent amount of time that is not that interesting, so I have run them in advance. We can take a look at the finished results of a topology study here with the same setup here. I can go take a look at my results and we can see what SolidWorks has determined is the best stiffness to, the best stiffness to mass ratio and reducing the mass by 75%. And so I said we can add the other goals of frequency. So I can take a look over in my other study here where we have added a frequency goal to this. So this will also run a frequency analysis as well as a linear static analysis as part of this. And I now have this frequency constraint, which makes sure that my first mode shape has a frequency greater than 150 hertz. And so we can see how that changes our results here. With only that being added, it's removed material in a different way to give it that higher frequency. And then the really cool thing about this is we can generate a smooth mesh from it. There we go. And it will smooth out those sort of jagged edges and give me a nice smooth mesh body. And I can export that smooth mesh from here into either a new configuration within the existing file or into a new part or add it to my current active configuration.